So after we simplify an arithmetic problem, we want to make sure that we can read it correctly. So the first thing that I'm going to talk about is the concept of a mathematical term. So terms are separated by additions. Commutativity is allowed as long as the term owns the sign in front of it. We may want to write an expression like this: 2 minus 3 minus 4 plus 5. But we want to think about it like a 2, a -3, a -4, and a 5 all being added together. And so each of these are terms. Now, because they are being added together, we can commute, meaning that I could write this as 2 minus 3 plus 5 minus 4, let's say. And then using associativity, I could think of this as 2 minus 3 plus 5 minus 4, which is a -1 plus 1 to 0. Factors are expressions which are glued together by multiplication. For instance, if you have 2 times 3, this 2 and this 3 are factors. If you have something like 2 times 3 plus 5, that 2 is a factor, and that 3 plus 5 together is also a factor. Now, it's true to say that inside of this factor there are 2 terms, but taken as a whole, that is one factor. If we have 2 times 3 to the 5th, this 2 is a factor, and this 3 to the 5th can also be considered a factor. Next, a mathematical term is glued together by factors in the numerator and factors in the denominator. That is, if I have something like this 2 and this binomial factor, 3 plus 5, are the 2 factors in the numerator. This 7 plus 9 is a factor in the denominator, so this entire thing here be considered a term. Then here, and 11 to the 13, 14 all being multiplied together. That -1 into the 13 and 14, these are all factors, or factors in the numerator if you want to consider the denominator a 1. Collectively, those factors glue together into a term. That would be the second term in this expression. You could make 2 terms a single term by enclosing it in parentheses. For instance, if I were to write 2 plus 3 plus 5, obviously here I'm looking at 3 terms. But if I were to write 2 plus 3 like this, put that in parentheses, and then write plus 5, I'm actually looking at 2 terms here. The first term is this entire object, that's 2 plus 3, which consists of a factor that has 2 terms inside of it. So this entire thing here is considered one term, and the 5 is our second term. This is important to understand because often we'll see fractional expressions like this, 2 plus 3 divided by 5. And we always want to consider a fraction as a single term in the numerator and a single term in the denominator. Now, those terms may be made up of many factors, but still a single term in the numerator and a single term in the denominator, meaning that I want to consider this as a 2 plus 3 as one term and the 5 as another term in the denominator. Recall, if I have 4 times 5 over 6, let's say, I could do something called cross simplification. And that is, if I see a factor in the numerator and a factor in the denominator that are both divisible by a number other than 1, I could divide both this factor, say by 2, because that is the greatest common factor between 4 and 6. So 4 divided by 2 leaves you with a 2, and 6 divided by 2 leaves you with a 3. And I could write this as 2 times 5 over 3, which in turn is 10/3. This only works if there is one term in the numerator and one term in the denominator, and you are cross-simplifying factors. Okay. This is a very common mistake for many students. Let me show you a wrong example. 4 plus 5 over, let's say, 6 times 5 plus 7. You may be tempted to say, this 4 is divisible by 2, so divided by 2 is 2, and 6 divided by 2 is 3. You could write that as 2 plus 5 over 3 times 5 plus 7. This is absolutely incorrect. 4 plus 5 is not written as a single term. It has two terms. So you cannot cancel this out because this 4 is not a factor in the numerator. What if you had something like this? I absolutely can simplify this 4 and 6 as 2 and 3. Why? Because 4 times 5 plus 7 is a single term glued together by multiplication. Okay, one factor is a 4 and a second factor is 5 plus 7. Together that makes a single term in the numerator. And the denominator is a 6, again, a single term in the denominator. When you have a single term in the numerator glued together by multiplications and a single term in the denominator, that is when you can cross simplify our factors. And this results in 2 times 5 plus 7 over 3, which is 24 thirds. Order of operations can be applied to each term, numerator, denominator, and parentheses independently. Also, a fraction can be simplified at any time, as long as there is only one term in the numerator and one term in the denominator. Here, I can simplify these two factors, 6 over 4, because again, that reads as a single term in the numerator and a single term in the denominator. So I'm simplifying these factors. At the same time, I'll just compute 5 plus 7. Also, that 2 squared, I know that's 4. That 3 plus 6, I know that's 9. And here in this denominator, 1 plus 2, I know that's a 3. 5 minus 3, I know that's a 2. Here is a 6 and a 2 since I have a single term in the numerator and a single term in the denominator. And again, that is one term. There are two factors. A 5 minus 3 is the first factor, and a 6 is the second factor. But it's glued together by that multiplication, so that's a single term in the numerator and a single term in the denominator. So I can divide that by 2 and get 3, divide this by 2 and get 1. And also 1 plus 2, I know is 3. So this leaves me with 3 times 12 over 2 minus 4 times 9 over 3 plus 2 times 3, and 1 times 3 is just a 3 there. And now here, this 12 and this 2 can simplify. That's a 6 and a 1. This 9 and 3 can simplify. And this 3 and 3 can also simplify. I know that 3 times 6 is 18. 4 times 3 is 12. Here I'm looking at 3 terms, an 18, a negative 12, and a 2. I can rearrange this however I see fit, as long as the term owns the sign in front of it. So that negative 12 is a negative 12 anywhere I move it. So lastly, for a capstone example, the first thing we want to do, apply order of operations to every term or expression in parentheses, as well as any fractions that have one term. And again, it could have multiple factors in the numerator as long as they are multiplied together. That makes a single term. Okay, here's a big expression. The first thing I want to do is clean this up as per my previous video. So here the divided by 5 minus 2 squared means the 5 minus 2 squared is in the denominator. 3 times 6 is in the numerator. Minus negative is the same thing as plus. 5, 2 minus 8. Plus a negative is just minus 35. And divided by, and then in parentheses, negative 2 minus 5. That negative 2 minus 5 is in the denominator. And the same thing here, minus 10 1 plus 2 is in the numerator, and that divided by 5 means the 5 is in the denominator. Compute this by applying order of operations independently and simultaneously to each term, numerator, denominator, or expression in parentheses. So that 3 times 6, I know that's 18. 5 minus 2, I know that's a 3. 2 minus 8, I know that's a negative 6. Negative 2 minus 5, I know that's a negative 7. This 10 and this 5 can simplify. I could divide both of them by 5. So 2 and 1. And 1 plus 2, I know that's 3. Here, 3 squared, I know that's a 9. 5 times negative 6, I know that's a negative 30. Negative 35 over negative 7, I can write as positive negative 35 over negative 7. And negative 2 times 3, I know that's a negative 6. So that becomes 18 over 9 minus 30 plus negative 35 over negative 7 minus 6. 18 over 9, I know that's a 2. And over here, negative 35 divided by negative 7, I could divide both of them by negative 7. So that leaves me with a positive 5 over 1. So that leaves me with 2 minus 30 plus 5 minus 6. And again, I'm looking at this as 4 terms, a 2, a negative 30, a 5, and a negative 6. I could rearrange them however I want, as long as they own the sign in front of them. 2 plus 5 is 7. Negative 30 minus 6 would be negative 36. And this leaves me with negative 29.